Okay, basically I'm standing for Harold Gibson, who's the director of Metal Earth and Mineral Exploration Research Center. I'm the associate director for Mineral Exploration Research Center, and I'm really not going to talk too much about the question because we're just starting to address these things, and probably in a few years we'll be able to better address the question. But I'm going to tell you about what we plan to do for Metal Earth. It's a brand new research and development program, which has just recently been funded, basically just starting to implement it now. And it's an integrated 4D metallogenic study focused on the Canadian Shield. So the outline of the talk is what is Metal Earth, how we're building scientific capacity at Laurentian, the strategy and activities involved with the program, and the outputs and anticipated outcomes. So Metal Earth is a brand new project. It was inspired by a new research funding initiative by the federal government called the Canada First Research Excellence Fund. Oops. Yeah, okay. It is essentially $104 million of cash and in-kind contribution, and it's being led by the Mineral Exploration Research Center, but it's the Mineral Exploration Research Center, or MIRA, is essentially the research arm of the now named Hartwell School of Earth Sciences at Laurentian University. So we put a proposal together for the fund, and they granted us $49 million over the 7 years, but we've also raised additional cash and in-kind from other funding agencies and partnerships with provincial and federal government surveys, also with other academic institutions and industry partners. So we really wanted to, when we put the proposal together, we spent over a year doing this to really put together a proposal where we thought we were going to address significant knowledge gaps in exploration-based R&D, research and development. So we did this by getting working groups going at Laurentian to look at, and mostly focusing in on gold and base metal deposits. That's our area of expertise primarily. We also brought in industry experts to talk to us about where they thought gaps were. People like Jim Franklin and Howard Poulsen. We had discussions with government and academic colleagues. We visited all the government surveys that are involved in the areas that we plan to work in. We held industry and academic workshops. And what we learned from all of this is a major impediment to exploration success is how to identify metal-endowed areas from the vast areas that are geologically similar but have less or no mineral endowment. So what is Metal Earth? It's an applied research and development program involving a strategic consortium of outstanding Canadian researchers from academia and allied Canadian and international research centers, government and industry, led by Laurentian University. And it will transform our understanding, we hope, of Earth's early evolution and the fundamental processes that govern mineral endowment. And some of the talks here already are interesting in just in looking at the overall architecture of cratons and how that affects mineral deposits, an important part of this. So what we'd like to do is make Canada a world leader in mineral exploration. We've lost that with respect to the amount of dollars spent to Australia. We'd like to regain that or help to do that. And a world-class innovator through open source delivery of new knowledge and development and implementation of new technologies. So our goals are to build on existing knowledge. There's a lot of data out there already, as we've all talked about, of ore deposit districts to resolve ore system scale controls on mineral endowment. So this is a change for Laurentian. Most of the research we've done through MIRA has been deposit scale research and not so much at camp scale. Well, now we're going to go from deposit and camp to craton scale, trying to better understand mineral or mineral systems. So we hope to be able to image entire ore and non-ore systems at full crustal mantle scales to identify key geological, geochemical, geophysical attributes of metal sources, the transport pathways, and what might be, like Dan indicated, the traps that may control economic concentrations of metals. And so what we want to do is try and relate deep earth features to specific distributions of ores. And we also want to place equal emphasis on the less endowed. People always do a lot of research around the camps and around the deposits. Much less has been done in the less well-endowed areas. So what's the difference? Well, we don't really know. So that's one of the goals here. And we'll do this by creating a lot of new data, geophysical data, geoscience data, and integrate all that into 3D and 4D models, and try to address the significant challenges of deposit to craton scale data integration to aid in the discovery of new deposits. We've got a lot of collaborators on this. We have 6 university collaborators on the left. These are the geological surveys that we have as partners on this project. We also have other research centers. We have Carnegie in Washington, CET in Perth, and CODES in Hobart. And then we have a number of companies. MIRA Geosciences, is going to help us a lot with the 4D visualization side of it. Merarco and SEMI are both at Laurentian, and they're going to help us with also visualizing the different data sets. We've originally, this was sort of was put together when we put in the proposal, which was about a year ago, and the companies that we approached are ones that were sort of critical to the areas we wanted to work, but we're working on basically developing new partners. So it's an HQP focus on this as well. So, you know, there's a lot of talk here about HQP. I look around the room and I look in the mirror and I see that a lot of us who've got a lot of experiences are growing older. We have to have new geoscientists, new geophysicists come in to continue on with the industry. So that's a big thing here. So we're basically hiring a lot of people to help us with this project, and that's what a lot of funding will be for. So there's going to be 5 full-time, new full-time faculty positions. 4 of these are at Laurentian. There's a chair in exploration targeting. We've interviewed and we've selected a candidate, so hopefully we'll be able to talk about this a little bit more in a month or so. That's happening right away. There's an exploration seismologist that we've interviewed for, or we're in the process of interviewing, so those 2 are happening right away. There'll be a new Precambrian geologist at Laurentian, and that'll happen in early 2008, and an Earth system modeler and modeling and data analytics, that'll be also at Laurentian. But we're also helping with the University of Quebec at Chicoutimi, and they'll have a new position that will be working with us on some of the project as well. There'll be a lot of research associates and postdocs, and I think somebody mentioned here that the best output you get from these is if you hire these people on a longer-term basis, and MDRU has had some success, so I think a lot of these will be research associates with longer-term contracts. We have a whole bunch of technical support positions. We're going to have, we estimate, 30 PhDs, 40 MScs, and 100 plus bachelors. So our strategy is to focus on Archean greenstone belts, which represent 80% of Earth's history. We've got a lot of experience with dealing with these in the past at Laurentian. They represent 30% of Canada's far north exposure and about 50% of Canada's metal wealth with respect to gold and base metals. We are looking to determine the processes responsible for differential metal endowment in the Archean, requiring new understandings of secular changes in the evolution of the Earth, and Craton belt district to deposit scale research and integration. And I'll show you how this all fits together in the next slide or 2. And then again, we want to study the endowed and the less endowed, and then the integration of all this data into some sort of a visualization and an evaluation model. So it's basically broken down into 4 components. There'll be a Craton scale research project that's going to look at the whole the slave, the superior and the slave Cratons, but these are more compilation scales with some analytical work done in areas that we need to better understand things. The Transect research is boots on the ground stuff. I'll talk a little bit more about that in a minute. And then a little further down the road, we're going to get into thematic studies, where we find areas where the initial projects are showing interest. That's where we'll put in specialized studies. And then last, the data analytics. So the area that we're going to cover here is basically the area in pink here, the superior down here, and the slave up in here. And that'll be the Craton-wide project. I'll talk a little bit more about what we'll do in that in a minute. But the boxes are the areas where we're going to put boots on the ground stuff, and that'll be transects, geophysical transects, as well as geoscience transects in these areas. So we'll be looking at the really well-endowed Abitibi greenstone belt, comparing that with the Wabagoon. And we also want to apply what we learned from really well-understood, geologically understood areas in the south, where there are lots of deposits, areas that are less well understood in the northern part of these Cratons. So we're starting the Craton research right away. We're looking for a research associate to help us with basically improving our understanding of the isotopic story in the Cratons on the broad scale, to better understand Cratonic architecture. And so there's a large archive of work that's been done for uranium-lead geochronology across these Cratons, but what hasn't been done is going and looking at these zircons for isotopic systems, which will also tell us where these terrains are juvenile, where these terrains are contaminated by older crust. A lot of this work has been done successfully in the Yilgarn, and so we're sort of emulating that. So we're going to go back to the archived zircons. There's about 3,000 that we can figure that are in archives of university and government labs, and we're going to redo these zircons for these isotopic systems. In addition to that, we've got a mantle group, which is essentially University of Alberta, Graham Pearson and Steve Shirey and Rich Carlson at Carnegie, and we're going to look at basically mantle characterization of mantle reservoirs that supplied the magmas that are in these various Cratonic areas. The transects, basically, that's starting this summer as well. They're going to be across endowed, gold-rich, ancestral fault systems and volcanic centers that host gold and or base metal deposits, and less endowed ancestral faults compared to endowed and less endowed in volcanic centers. This will be collection, integration, interrogation, and visualization of complex multi-parameter geoscience data. So we're going to basically do transects across these areas using seismic, 2D seismic, regional scale, and high resolution. We'll do magnetotellurics along the same profiles, gravity, and then as well we'll have teams out collecting geoscience data, geochemical, and geophysical data. Try to integrate all these together for these transects, or basically the visualization of all the data sets, as well as archival data, and create slices from mantle to crest, where we can try and visualize all this data. The thematic research will be coming in later, and as I mentioned, that will be in areas where we find interesting things from the other projects that we can then focus in on general themes such as fluid, magma, heat pathways, difference between mantle in these, the mantle sources in these different areas, and Archean tectonics and metallogenic. And then the data analytics part, there's a big challenge of all this data that we have. We're going to be adding to this. How do we come to grips with all this data? It's non-uniform, it's sparse, it's multi-parameter, geophysical, geochemical, geological. What do we do with all this stuff? How do we put it all together? The data is we'll be imaging the data in 3D space, interrogated in 3D space, and then we'll do the 3D visualization. Just a little further, the geoscience data from the Cratons, Transect, and Thematic studies are going to be integrated, analyzed, interrogated, and visualized using the GoCAD Common Earth model. And we're in partnership with MIRA Geosciences, but we're also talking with IBM Cisco about how we can bring artificial intelligence in machine language to try and interpret all this data in ways that, you know, there's a lot of the data that hasn't been looked at adequately. How do we deal with all this extra data? Look at other software, build on established best practices, visualization using Laurentian, and we're also we have a virtual reality lab at Laurentian with Morocco, and there's University of New South Wales wants to help us on this as well. And then ultimately what we'd like to do is see what is going to help people find new deposits and commercialize that with the and so basically, just to go through it now, there's the 4 Transect, the 4 research activities, and hopefully the output. There'll be a lot of new knowledge in HQP created out of this, reports, maps. It'll all be open source because it's all government funded. And then hopefully develop new technologies and commercial products, and hopefully it will increase scientific capacity, will create leadership, more leadership in Canada for mineral exploration research, create a toolkit which should help exploration companies to maybe better understand what it is they would like to focus in on in a certain area for a certain commodity, and then hopefully see new mines. And also what is also driving this is helping us to move companies into doing more work in the north. And so this is a big thing for governments these days, so that's another part of the whole package that we'd like to do with this metallurgy program. So that's it.